What is integration? Integration is a way of adding slices to find the whole, and integration can be used to find areas, volumes, central points, and many useful things. What is the application of integration in real life? In electrical engineering, integration is used to determine the exact length of power cable needed to connect two substations which are miles away from each other. Spaceflight engineers frequently use calculus when planning for long missions. It is easiest to start with finding the area under the curve of a function, like this.
Why the integration is important? Integration can dramatically increase productivity, reduce waste time due to manual processes and IT resources, and can help your business scale for future growth. You can make quicker decisions when you have access to all company data and watch trends that can impact the business.
But wait, what is the use of cylindrical shells method? With the method of cylindrical shells, we integrate along the coordinate axis perpendicular to the axis of revolution. The ability to choose which variable of integration we want to use can be a significant advantage with more complicated functions.
Volume by cylindrical shell are divided in two types, which is case 1 and case 2. For case 1, cross-section parallel to y-axis, while case 2, cross-section parallel to x-axis.
For example, let's solve a question with cylindrical shells method. Winter has arrived and Mr. Stephen's house was affected. He and his family was planned to clean the pool in their backyard, but the pool was completely frozen. His wife suggested that they need to release the frozen water. But how? They have to figure out what is the total volume of the frozen water so they can estimate the right place to dump it out. Consider the pool was as the diagram shows. Now, let's solve it step by step. Step 1. Read the question carefully and find the information. From the question, we know the pool was revolved about the x-axis, so this is the information that we get. Step 2. Find the formula. And now, for the step 3, solve the problem. So, based on the formula, we have to fill it with the correct information, such as Ry that we got before is equals to y minus 0, which is also equal to y, and Cy that we got before is equals to y to the power of 1 over 3 minus 0, which is also equal to y to the power of 1 over 3. After that, we can continue to the next step to solve the problem. But remember, you have to integrate the number carefully so you will not lose your marks. And finally, we got the answer.
Now, let's move to the next question.
question is, find a formula for the volume of the solid generated by revolving the n enclosed by y equal to 0, x equal to 0, and y equal to a plus cx. For 0 less or equal by x and 2 pi more or equal by x and a more and equal to 1 about the y-axis. Figure 4 is volume of a solid revolution generated by a sine curve around y-axis.
Bro, what are you talking about, man?
The volume of the solid of revolution described in this example is given.
No? Macareno. No? Huh, okay.
Next, calculate the two integrals separately. After that, let u equal to x and v prime equal to sin x and use integration by parts to obtain. So last but not least, the final answer is v equal to 4 pi the power of 3a minus 4 pi square.
For conclusion, we have the ability to find the effect of changing condition on a system. By studying this, we can learn how to control a system to make it do what we want it to do. And application integration is the effort to create and to address data quality problems introduced by new applications.